అందరికీ నమస్కారములు. శుభోదయం. సర్వేభ్యో నమో నమః. గురుభ్యో నమః. Today is the fourth day of our classes on Vedic mathematics by Dr. Gautham Mukherjee ji. We will start the session with reciting Vande Mataram and chanting Prarthana. So let us request our Guruji Gautham ji to recite Vande Mataram, please.
Vande Mataram, Vande Mataram, Sujala Suphala Malaja Shitala Shashamala Mataram, Vande Mataram. Shubhayosna pulakito yamini Pulakusumita durmadala sobhini Shuhashini Shumadhura bhashini Shukhadam varadam Mataram Vande Mataram Vande Mataram.
Vande Mataram. ధన్యవాదములండి గౌతమ్ జీ. ధన్యవాదాలు. థ్యాంక్ యూ సో మచ్. నౌ లెట్ us request కృష్ణ కుమార్ గారు టు చాంట్ ప్రార్థన ప్లీజ్.
సార్ కోహోస్ట్ చేయలేదు.
ఓకే.
సర్వేభ్యో నమస్కారః. Let us meditate for a minute. Please relax your body and mind. Close your eyes. Take a deep breath and focus on it. Let us chant Omkaram 3 times. Om Gananam Tva Ganapati-gum Havamahe Kavin Kavinam Upamashravastamam Jyeshtarajam Brahmanam Brahmanaspata Anashrunvannutibhissedasadanam. Om Sri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinama Vitrayavatu. Om Sri Mahasaraswatयै Namaha. Gurureva Gati Gurumeva Bhaje Gurunaiva Sahasmi Namo Gurave. Na Guroh Paramam Shishurasmi Guroh Matirasti Gurau Mam Pahi Guru. Jnananandamayam Devam Nirmalasphटिकाकृतिम् Adharam Sarva Vidyanam Hayagrivam Upasmahe. Shruti Smriti Purananam Alayam Karunalayam Namami Bhagavatpada Shankaram Loka Shankaram Shankaram Shankaracharyam केशवं बादरायणं सूत्रभाष्यकृतौ वन्दे भगवन्तौ पुनः पुनः। ईश्वरो गुरुरात्मेति मूर्तिभेदविभागिने व्योमव्यत्याप्तदेहाय दक्षिणामूर्तये नमः। असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय। ओम शांति शांति शांति। मातृदेवो भव पितृदेवो भव आचार्य देवो भव अतिथिदेवो भव। ओम सहनाववतु सहनौ भुनक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ओम शांति शांति शांति। श्री गुरुभ्यो नमः। हरि ओम।
ధన్యవాదములండి కృష్ణ కుమార్ గారు. Thank you so much. Now let us request our Guruji, Gautham ji, to start the webinar, please.
सर्वेभ्यो नमो नमः। सभी को नमस्कार। Last time we discussed about this called Vedic one-line method for evaluating the recurring decimal. It was what? Instead of dividing by 19, that works only when the last digit, the unique digit, is 9 in the denominator. So we started with 19, something by 19, so 1 by 19, and instead of dividing by 19, we divided by 2, but in a special way. What's the special way? Not like that you divide by 2 and say that it's 0.5. No. We just collected all the quotient and remainders. Quotient and remainder used as a tens digit for the next one. Like 1 is remainder and 0 is quotient, so it becomes 10. So or look like that. We write it in the left and below. That tens digit it became, and it became 5, and then again that way 5 again divided by 2, it becomes 2 and 1, 12, again 6 and 3, 3 became 1 and 1 is 11. That way we proceeded. Now the logic was that it was a expression was the binomial expansion of 1 minus x to the power minus 1. And that is, this logic of this remainder being used as a tens digit is that when you divide by 2, actually we found in the binomial expression that actually we are dividing by 20. We are not noticing. Suppose you divide 1 by 20, it will say 0.05. 0.05. It will end there. But no, it is, we are dividing by 19, so it is something more. You remember that bracketed expansion, infinite bracket expansions. So it is not ending at 0.05. It is something more. What is the something more? Said that something more will come only when we also consider the next expression of dividing it by 2 and put it that 2 is there and 1 remainder. This remainder is the unutilized part, that 1 plus that unutilized part. It could not be divided by 20, so this remained, and that will contribute to the tens digit so that the next step comes. That is the logic I found like that. It has connection with it is based upon the binomial expansion of the 1 minus x to the power minus 1, because 19, 29, these numbers can be expressed as like this. If suppose n is equal to 3, you will put, then 10 into 3 is 30, minus 1 is 29, 1 by 29. But this is 10 into 3, that is 30. So 1 by 29 can be expressed as like 1 by 30 into 1 plus 1 by 30 plus like this one, and then 1 by 30 into 1 plus 1 by 30, again 1 plus 1 by 30, and so on infinitely. So those parts are coming always, that remainder is unutilized part. Again, we have to divide it by, say, 30 here. So always this unutilized part is the remainder, and that plus again this will, I'll continue with divided by using that one, and unutilized part with the rest of this thing, it will go along like that. Now, how much we have learned. To understand that, I want your reaction. So what we will do? What we will do when suppose you are given an exercise. I want that, say, something by 39. Say, I want that not 15, not 15, no, not 15. Say 14 by 39. Sorry, 14 by 39. How will you proceed? I want your reaction from the participants, general participants. Not Chiti Babu Gar. What will be my starting point? Suppose I want to evaluate this one, 14 by 30. Govindji. And whoever want to talk, please unmute yourself and also put on the video.
Let's start with 4, right? Ekadikena Purvena.
Ekadikena Purvena. Say this becomes
3, 4. Yeah.
3 becomes 4. So I start dividing 14 by 4.
Yeah.
And find it. Not 14 by 4. Do not say that it is 14 by 4, 3.5. No, it is not that. Instead of that, what is the quotient and remainder? We do not want that it is 3 by 4. No. 3.5. Not is equal to money. We do not write 3.5. We do not like this. I do not want 3.5. What do we want? Quotient and remainder. When you divide 14 by 4, what is the quotient and remainder? So first we start with write a 0 and dot 1, 0 and dot 0 point. What is the quotient and remainder when I divide 14 by 4?
3, 2.
3 and 2. Then
26. No, 5. It should be 23 by 5. No?
3 and 5. 5 and
3. 5, 1. 1 and 1.
No, it is not 5. It is 35. We look like this and become.
Yeah. Sorry, correct. 35. 8 and 3. 8 and 3.
8 and 3. Yes.
38 and 6. 6.
9, 2.
9, 2.
Right.
Yeah.
9 and
7. 7 and 1. 4 and 6. 4 and 1.
4 and 1.
3. 3 and 2.
5, 3. Repeats.
5, 3.
Repeats. So as soon as you see, this is 14. As soon as you get 4 as a quotient and 1 as a remainder here, you end it. You don't have to, because it will yield the same thing. So that it comes back. Whenever when it comes back, single digit, it will come as single digit. It is a double digit, something with a tens digit here, that will come as the same thing as the remainder. Suppose we had started with 34 by 39. Had it been 4 and 3 here, we would have stopped it here. Otherwise, also see here, also you can see that property. 4 into 4 plus 1 is 17. 7 we write here and 1 carry. Whatever is carry from this side is remainder from this side. Now, 7 into 4 is 28 plus 1 is 29. We write 9 and 2 here. 9 into 4 plus 2, 38. 8 and 3. 8 into 4 plus 3 is 35. 5 into 4 plus 3 is 23. And 3 and 2, 3 into 4 plus 2 is 14. It comes back to 14. So you can start either way. But here, there is one peculiar thing which is not there earlier, that if we divide it into half like this, 358, the corresponding addition of the digits doesn't come to 9. 3 plus 9 is 12. 5 plus 12, 5 plus 7 is 12. 8 plus 4 is 12. It becomes 12. Also but the addition of the remainders, quotients doesn't add up to 9. It added here is 12, but here this 2 plus 2 is 4. That 4. 3 plus 1 is 4. 3 plus 1 is 4. 2 plus 2 is 4. That is coming to adding of remainder coming to 4. Why it is so? Because 39 is not a prime number. It is a composite number. So it has some difference. So it is composite number. Also see, earlier what happened? In case of 19, it ended in 18 digits. 29, it ended in 28 digits. But here, this being composite number, sometimes of course this becomes a sub-multiple of that. Here, 39 minus 8 is 39 minus 1 is 38. It is neither 38 digits or neither 19 digits. Could have been 19, but not, because there are certain other numbers which are actually, there are this 13 by 39 and there is 26 by 39. These two numbers are actually, what is the 13 by 39? You do 13 by 39. You do 13 by 4. 13 when divided by 4, how it happens? My quotient becomes 3 and remainder 1. She comes back 13 immediately. So it becomes 0.3333. Similarly, 26 divided by 4, 26 by 39.
24 and
This was 13 by 3. Because those are actually, these are nothing but, if we cancel it, 1 by 3 and 2 by 3. So we'll come back. So it will point this 6 quotient and 2 remainder, always like this. And it will come back again to 6 quotient and 2 remainder. It will be 6666. It will also be 333. So these two are actually, these 38 minus 2 is 36. So these 36, there are numbers. The 36 actually, this is a sub-multiple of 36. So there will be 6 cycle of 6 length each. Here we get 23 by 39, 35 by 39, 38 by 39, 29 by 39, 17 by 39. These all will be coming in this cycle. But suppose I do 10 by 39. It will not come here. It will be again another cycle, the 6 cycle of 6 length each. The peculiarity, you try yourself sometimes. So you understood the case, exactly what to do when you get something, something divided by ended in 9. Now you tell me what I will do. Suppose I get, suppose I want to say 16 by 23. What I will do, I want to evaluate 16 by 23. So, whatever we're discussing, sometimes we are making note, na? That will be good. What is the starting point?
By 0.51.
Because my binary formula works with something ending what?
29 per code. 16 by 29 we can go like, but 16 by 29.
No.
69
No.
into 3 into 3.
Yeah. Who told? Yes.
Govindraj.
Yes. So, denominator should be how much? So, it is 3. So, you have to, how to make it 9? How to make it 9? Yeah. This 3 has to be made 9. How? Multiply by 3.
Multiply divide.
Then only it will be
69.
3. So, it becomes, yes, 69. And in the numerator?
48.
48.
So, how to start? What to be divided by what?
48 divided by 7.
48 divided by 7 in a special way. The quotient, sorry, this quotient remainder format. So, is equal to 0.48. You do not write in the same line because this is our just noting that what is the procedure, but actually line I will write like this. 48 divided by 7, how much?
6.
6 and 6. Yes. Now
9-3.
9-3. Yes.
5-4. 7-6.
45.
45.
7-3. 6-3. 6-3.
6-3. Sorry.
6. Yes.
56. 5-1. 2-1.
It has actually linked 22. Let us not complete. You just verify from a calculator that you are reproducing the same correct digits. So it is a length of, I think it is linked at 22, most probably. It could be 23 is a prime number. So it could be, it will be always less than that, certainly. It can sometimes it becomes 1 less than, like it could have been 22 or some multiple of 22. It could have been 11, but here it is actually 22, not 11. So that is the idea. So you got the idea how to make it. If it is not but it is other than 9, what to do? You multiply by appropriate number, both the numerator and denominator, and start the same way. Okay. Thank you. We'll come back whenever required. Any
Gautham ji, sorry,
so
I
here
missed.
we did.
Gautham ji, sorry,
Huh?
I missed one part. Agar the multiplication may doesn't turn out to be the units place 9, what will happen? मतलब अभी 25 है.
25.
Agar denominator is 25, it can't, it doesn't convert into 9 any point. Units.
Oh, no. That I told you that this one actually, this particular recurrence method is valid only for denominators ending in 1, 3, 7, and 9. Otherwise,
Okay.
I can go back. I'll see.
No, I
See,
understand.
5 means
Okay.
there is a 5 here. So you have to appropriately, you have to multiply both the numerator and denominator by either it is suppose even or it is ending in 5. So you do multiply both the sides by this one, say 74 here. So here actually it is actually a third type. Third type means it is neither it is purely 2 and 5 or ending into 1, 3, 7, 9. It will be something else. So you multiply both the numerator and denominator with something else, something here, and then you convert it. Suppose it was like 1 by 6, say 1 by 50, something by 15. I have shown there. Also there, as you told, 15, 25. 25 is very easy. You know, should I tell you how to something divided by 25?
It's a 5 division, 5 multiple division.
Now, especially 25, what is the procedure? Suppose you give a number, say you do say 29 into 25. 29 divided by 25. You know how to do it?
Make it
You simply multiply by 4.
400. Denominator 100.
Oh, sorry. Oh, multiply by 4, right? 6. 6 and
116.
156, no?
116.
Yeah.
116.
Oh, sorry. 116.
Divided by 100.
100. So this is equal to 1 point. It is terminating decimal, no?
Yeah.
So something like 25 has no problem.
Okay. Terminating.
So what anything else other than this? So that means that when something is ending in or this even number or ending in 5, that can be done by appropriately dividing either in case of odd even number, we divide by something power of 5 to make it 0, or and it will be what will be remaining, that will be on the class of the 1379, or it is suppose it is ending in 5, so again dividing a power of 2, so that it becomes ultimately ending in 1379, and then you follow this number and appropriately you shift the decimal point. That is the idea. And 25 was purely power of 5, so it has a different procedure. As it told, it will be terminating decimal. Now, here we got this explanation of this, how it was working. Now, we also discussed that if it is say ending in 7, if it ends in 1, 3, or 7, you respectively we multiply both numerator and denominator by 9, 3, and or 7. 9 into 1 is 9. 3 into 3 is 9. Ending in 7 into 7. Ending in 7 into multiply by 7 ends in 9. Like 7 into 7 is 49. So 1 by 7 is become this like this. We started with that. 1 by 13 becomes 3 into by 39. We did it 23, 3 became 69. That way we did already ourselves. Now this becomes sometimes complete, or 39 becomes 6 into 6. 6 into 6. And here odd become, in case of prime numbers like this, it is full cycle, 18, for 19 it become 18 length, recurring length, 29 become 28, 59 become 58. But sometimes it becomes less actually, or some multiple like that. These are 13, this one, 1 by 3, it becomes like, okay, you please ignore this part. These are actually, these are used to those I collecting somewhere. It is just, you have to be, this part has to be ignored. Okay, now, there is a catch here. I told that for denominators ending in 1, you have to multiply by how much? Multiply, you have to 9. 3 and 7 are manageable somehow. Multiply by 3 is manageable. Multiplying by 7 is also sometimes manageable. But multiply something by 9, it makes it very high. Like, I want to evaluate 1 by 21. 23, it was all right. It became to 23, I multiply by 3, it becomes 69. But when I multiply 21 by 9, both sides, became 9 by 189. And the digit divisor becomes 18 plus 1, 19. Similarly, 1 by 31 becomes 9 by 279, and the digit divisor becomes 28. 1 by 48 becomes digit divisor 37. Therefore, it becomes also, I wanted to avoid multiplied by divided by 21 by landed up in dividing by 19, which earlier we avoided, 19 again quotient. And so finding quotient and remainder, always every step divided by 19, divided by 19. So we have to, this Vedic online method needs a change. Now, in this Bharati Krishna Tirthaji's book, he used some 9's complement method. This Vedic online method needs a change. He tackled this problem using a method called 9's complement. 9's complement is, so 9 complement of 4 is 5, but something 9, something subtracted from 9. Or say double digit, suppose 33, this 9 complement 666, and so on. But I found it that easily this, from the binomial consideration, actually this binomial expansion is the main logic behind this Vedic online method. So this 21, 31, 41, this comes under this format 10n, these digits are coming as 10n plus 1. 2 into 10 plus 1, 3 into 10 plus 1, 4 into 10 plus 1. So 10n plus 1 it comes. So these fractions are of the form 1 by 10n plus 1. And then binomial expansion, it will be applicable here 1 plus x to the 1 minus 1 instead of 1 minus x. And here what will get? Earlier in 1 minus x to the 1 minus 1, you remember that it becomes, everything was positive. 1 plus x square plus x cube plus x to the 4. But here it becomes alternates. 1 minus x plus x square minus x cube plus x4, that way. So 1 minus x, if I take common again, 1 minus x, again I common 1 minus x, all the brackets finally closes. But x, consideration is that x is less than 1. Therefore, I express this 1 by 1, or 10n plus 1. That means like 21, 31, and so on, as the expression of 20, 30, 40, etc. So here I should use 21, 31, 41, but I'm expressing in the format of 20, 30, 40, like what we did earlier in case of 19, 29, 39, etc. So here I clearly write like this. Suppose forget about n and you put it, suppose we make it n is equal to 2, for example. So I'm considering that 1 by 1 by 21, you see here, is equal to 1 by 20, 1 by 1 plus 1 by 20, like this, you write like this, 20 is out, and then it becomes 1 by 20, 1 plus 1, 1 plus 1 by 20 to the power minus 1, and we go 1 by 20 into 1 minus 1 by 20 plus 1 by 20 whole square, 1 by 20 whole cube, and so on. And then again I make common 1 by 20, 1 minus 1 by 20, 1 minus 1 by 20, 1 minus 1 by 20. Or something by, suppose it is instead of 1 by 20, it becomes, suppose, say 8 by 20. So 8 by 20 will be equal to 8 by 21. Sorry, 8 by 21. Say 8 by 21. Like it will be 8 by 20. 8 by 20 into 1 minus 8 by 20, 1 minus 8 by 20, 1 minus 8 by 20. That. So the procedure is that you have to start with 8, start dividing it by 2, but in a peculiar way. So actually I made it from 1 by 21, but initially I will not do that because there is some problem comes here, minus. So first I will, there is no minus. I will first take that example. Okay. Then we understand correctly. So earlier we did 14 by 41. Earlier we did 14 by 39, isn't it? Sometime back, we ourselves, together we evaluated 14 by 39. Here, let's do 14 by 41. What to do? Here, digit divisor becomes 4 itself, not ekadhikano purmena or ekanu, something like that. No, nothing like that. It is just 4 itself, because here also you'll find that in the binomial expansion. Instead of 19, in case of 19, it was also 20. We started with 20, but in case of 21 also it is 20. In case of 39, it became binomial expansion required presence of 40. Here also it is 40. So it do not change or anything. So divided by 4. 14 divided by 4. Now what will become 14 divided by 4? 3 quotient and 2 remainder. When you divide 14 by 4, it becomes 2 quotient,
Reminder.
3 quotient and 2 remainder. In case of 39, while evaluating 14 by 39, what we did? We made it 23, isn't it? But here, because of this minus expression, in minus operation in the expression in the binomial expression, here it will have to be subtracted. So you consider it as if it is like this. You make it, don't write it, because otherwise it will write in the expression, it will be in the line, will be disturbed. So imagine it is 2 and vinculum is equal to, it becomes 17, isn't it? So I wrote in the bracket. Now instead of dividing 4, like in case of 14 by 39 we did, instead of dividing 23 by 4, you do divide 17 by 4. So what will happen? 4 quotient, 1 remainder.
1.
Isn't it? Now you again consider it not like 14. You consider as if it is like this. So it becomes is equal to 6. This I have written in bracket. 6 become 1 quotient and 2 remainder. Now instead of 21, you do as if there is a vinculum here. But don't disturb the line. Don't write vinculum. You consider it vinculum. 20 minus 1. It is 10 minus 4. 20 minus 3. Here this 20 minus 1 become 19. So 19 again divided by 4 is 4 quotient, 3 remainder. And became 26. Then it becomes 26. Again 6 cosine 2 remainder, it became 14, came back to 14. So I did like this and 3, 4, 1, 4, 6. It has 5 lengths. There are actually 8 cycles of 5 length each is equal to 40. 41 denominator being a prime number, it will have a either 40 length could have been 40 length, or it will be some multiple of 40. Some multiple of 40 is 5, and there are 8 cycles of 5 each. It is like this. So I comes to white screen. I repeat this. You tell me. Side by side, I also do like this. 14 by 40 and 14 by 39. We compare these things. These 3 expressions we compare. Then you understand what is the mathematics behind this. Again, 14 by 39, first you do. Let's start with this. Everywhere we are only dividing by 4 only. Okay, 14 by 40 you write. Do it first. How much it is?
0.
It has no other procedure.
0, 3, 2. 3 and 2.
Oh, sorry. 49. How much? 3? No, 2.
5.
Here there is no other consideration. It is ending in. Answer is this. There is no because there is no recurring decimal point consideration here, because it is not ending in 1379. If it is ending in either 1379, it happens. But again, this procedure works only with positive procedure. Positive procedure works with ending in 9, and negative procedure works in ending in 1. Now, this 14 by 39, we repeat again. We have to divide 14 by
4.
14 by 4. But in a special way, what is that?
3 and 2.
3 and 2. And then
4 and 3.
No, 5. 5
5,
and
5, 5 and 5 and 3.
5 and 3.
9 and 3.
8, 3. Sorry.
8 and 3. 8 and 3.
9 and 2.
Yes. 9 and 2.
7.
7 and 2. 7 and 1.
1.
7, 1.
7
7
and 1.
1. 7 1.
4 and
4 and 1.
It repeats.
So it has 6 lengths.
3 and
4 and 1 means it came back to 14.
Yeah. Repeat.
Now, here, whatever I discussed, can you just do it? (14 divided by 4).
3. 3 and 2.
3 and it repeats.
5. 5.
It
5 and
repeats.
3. 5 and 3.
No, then that will happen 14 by 39 only.
Yeah.
What I told, what is the difference?
Negative. You should write vinculum.
So, but don't write vinculum. Vinculum should be in your mind.
Yeah. So 17.
17. So, as if 3 is vinculum, that means 20 minus 3. 17. We write in bracket. Now you do the processing with 17, not in 23. Then
3 and
4-1. No?
no
4-1.
4-1, sir.
4-1. But you do not say that it came back to 14. No, it didn't come back to 14 because it is not 14, but 1 and 4 vinculum. That means
06.
6
06. 6 or 06, you can write both the same. Now
1-2.
1 and
8-9.
no. It's not 21, but what? What should I write in bracket?
119. 19.
19.
19.
Now
4 and 3.
4-3.
4-3.
2-6.
Four two. 4-2.
6-2.
6-2.
Sorry, 6-2. 26. Vinculum.
14.
14.
6 to become 20 minus 6, 14. So came back to 14. What do you write now? Now it came back to 14 because 14 again I have to within bracket. Within bracket things I am dividing by 4. Not the actual thing, not the key which we got, but we after doing it vinculum, we wrote something in the within bracket. That bracketed thing we'll be doing. So now it came back to 14. Here it came back to 14 that way. Immediately you saw it that it came back to 14. Directly it came back to 14. Here you see 4 quotient 1 remainder. But here it is 6 quotient 2 remainder became 14. So what we do? 3 and here we put here. So we all the bracket, clear all the bracket, you write 0.3416. So you compare these things, that 14 by 40 is 0.35 ends, 8 terminating decimal ends there. But the binomial expansion, if you see, it is the positive one, and 14 by 39 will be something more than that. How much more? 0.35 is there, but there is something more. 8, 9, 7, 8, step by step it came like. And it is something, it has to be something less than 5. So it came 3 and 4, always is negative. And then it could not be, even suppose we make it positive. It becomes something, or say 2, it could have been 2, 3 or 4 anything, but no, it is 1. Suddenly always less. So it because of the minus symbol. So that is the idea. What is the comparison between these three? Gradually, when the numerator increases, the result becomes less and less. So you got it. You got this one. Similarly, for 31, I did it by. Now I come to the 21. First let me come to 21, which I avoided. For denominators of the form A1, we simply divide by A, but in a special way, take it like that, 1 by 21, here the digit divisor becomes 2, not anything more than 2 or something like that. Now, we follow like this. 1 divided by 2 is 0 and 1. Considering the binomial expression, we have to do it 10r minus q instead of 10r plus q. Then in the very first location it happens, not very first location, next. 10 into it becomes minus 0. Minus 0 or plus 0 didn't find difference. So 10 divided by 2 becomes 5. And 5 quotient 0 remainder. Now it comes at catch. 10 into this quotient becomes negative. So this whole thing becomes negative. Now the problem is that how to handle this minus 5 divided by 2. How to divide, quotient become 5, so we have to consider it to be minus 5. And remainder is 0. So there is nothing we can support it. Like earlier we did suppose even 1 and something vinculum is there, we can handle it. But something 0 and vinculum, it will be whole thing will be negative. So minus 5 by 2. Now some person could have told, okay, 5 divided by 5 and divided by 2 is equal to 5 divided by 2 is equal to 2.5. And so 2 quotient 1 remainder become algebraically, mathematically is 2.5, but it is 2 quotient and 1 remainder. They may think that okay, minus 2 is the quotient and 1 remainder. No, it is actually, you have to find it. Quotient can be negative, but not the remainder. Remainder is negative, never negative. So we have to consider it. Minus 3 is my quotient and 1 as remainder. When you divide minus 5 by 2, minus 5 becomes, because see this expression, minus 3 into 2 plus 1 is minus 5. Because quotient can be negative, but not the remainder. So result becomes like this, 0, 5 and 3 vinculum. We put it in the vinculum format. And then 10 into 1 minus 3 becomes 13. 13 divided by 2 is again 6 that way. Now let me do it on a white screen. 1 by 21. It will be slightly challenging. It will require slightly. One divided by 2. What quotient, what remainder?
Five zero.
Huh? 1 divided by 2 is quotient and remainder?
5.
Earlier we did, no? In case of 19. 0 quotient, no? We did it earlier, no?
0 quotient, 1 remainder.
1 remainder. Then become 10 minus 0, means same as 10, 0. Becomes 5, no?
Zero
Now,
remainder.
0 remainder, yes. Five became 5 vinculum actually. Only 5 vinculum means that minus 5. Now minus 5 you have to divide by 2. What will happen? What is the quotient? What is the remainder?
2 quotient, 1 remainder.
No. Minus 3 quotient and 1 remainder. Now you first understand this. Because minus 3 into 2 is minus 6 plus 1 is equal to minus 5. So therefore, when we divide minus 5 by 2, it becomes minus 3 is my quotient and remainder. Now it is 1 and 3. This 5 became my minus 5. Okay. This we acted with that. Now result became 3 minus 3 vinculum 3 quotient and 1 remainder. Here, what will it do? You remember that 14 by 41 case? What will happen? 1 and vinculum 3, but in a negative context. Please tell. Should I write 7? No. We made it. It is already negative. So this will become positive now. So it becomes 13. It actually see, little difficult and understood.
Yeah.
So this negative thing has to be handled properly. Now 13 divided by 2 is how much?
6 and 1.
6 and this becomes how much?
Zero 8.
0.4, na?
Yeah.
Then 2 and no remainder. 4 divided by 2. Here actually I missed one point. Here I could have written in between 10 itself. Because I thought that since it is 0, minus 0 and positive 0 doesn't make it sense. Because we are writing with bracket. Here we just missed that bracket. Here it could have written it like this. Here it could have been written. Anyway, now it should be how much? In the bracket, what should I write? Single digit vinculum doesn't look good actually. Single digit vinculum, it could have been 2 vinculum, but something supported with vinculum, I simply write minus 2. And again, minus 2 divided by 2. Minus 2 divided by 2 is how much? Quotient, how much remainder?
5 and 5. 3.
No, not 5.
5.
Minus 1. Minus 1 quotient and 0 remainder. No. So it is this one. 1. Like this. And 1 became minus 1. It became 1 within bracket. Came back to 1. So 1 by 21, I got the answer as, I will repeat this. Don't worry. So got some confusion. I will repeat again. 0. It will have 6 digits. 6 digits. 5, 3 vinculum, the 5, 3 vinculum we collect, 0 we collect 0, 5 we collect, 3 we collect, then 6 we collect, 2 we collect, and this minus 1 vinculum we collect. So this is the answer of 1 by 21. Now we clear the vincula. Is equal to how much? Zero 0.53 is how much?
47.
0.047 and 6
19.
19. So this is my answer of 1 by 21. I verify. Four 7619. Yes, 047. So you got the idea? You got it? How you got it? Should I repeat the whole thing?
Briefly, sir.
Yeah, first
Briefly again.
3-4 steps.
Or so you let us do something else by 21. Something else by 21. You do something else by 21, excepting because 21 is a multiple of 7 and 3. Excepting anything product multiple of 7 or 3, something else you do. Something by 21. There can be there can be 1 by 21 to 20 by 21, isn't it? But all of them are not actually fractions. Some of them are coming out the form something by 7. 3 of them are coming as 1 by 3, 2 by 3. 7 by 21 is 1 by 3 and 14 by 21 is 2 by 3. So there will be this, therefore 21 minus these 2 or is 18, and this 18, it is some multiple, cycle is 18, some multiple of 6, and it comes to 6 cycle. So there is very, very big considerations are there. These are actually factors. This 3 factor is not there. These are not. There are 6 of them will be anyway coming out of that. So again, other 5 cycle. One of the 6 cycles of 6 into 6. One of them will be or multiples of 3. That is one cycle, but the rest 5 will be non-multiple of 6. I want that non-multiple of 6. So I say something by, say 8 by, do 8 by 21. Okay. So 8 by 21 is equal to 0. We do how much? 8 you have to divide by what? What is the starting procedure? 8 you have to divide by what?
2.
Because in case of 19, it was we ekadhikona purvana we did, but here we don't. It is itself. So it becomes how much?
4 0.
4 and 0. Here, first shape itself. Bracket, what should I write in the bracket?
Yes.
Becomes -4. Correct? Am I correct? See, 0 is my remainder. So 0 minus 4. 0 minus 4 is 0 into 10 minus 4 basically. So it becomes minus 4. Now minus 4 divided by 2 is
-2 0.
minus. We write 2 vinculum here because actually it is something supporting, no? Already 4 is there, we write this thing. Now this becomes 2 minor vinculum. But when you write in the bracket, what will happen? Again, this remainder is 0. So this will be
8. 8.
no, 2 divided minus 2 divided by 2. 0 into 10 minus of minus 2. That means 2. Now, next step.
1 0.
1 0. Again that thing.
-1.
It will come, negative will come twice actually in this cycles, but others will not. Now minus 1 divided by 2. What quotient and what remainder? See, minus 1 is the result. Sorry. Minus 1 into 2 plus 1 is equal to minus 1. So therefore, minus 1 is my quotient and 1 as remainder. So it becomes right like this, minus negative 1 and 1 as remainder. This becomes what in the bracket?
डिस्प्यूट करू द्या ना जरा बरे ना करेक्ट नाही मग
11.
11. It becomes positive.
Yeah.
Then
anything homemade is
5 1.
anything homemade is better.
5 and 1. Any mistake is there? Acha. 5 and 1. It becomes how much?
5.
In the bracket?
5.
5. Only 5.
8 divided by 21.4 correct. But tackle करता मग येता है करो explain करो सब पिंगड़ कर. Five divided by 2. Always divide by 2. In the bracketed part, you have to divide by 2.
2 1.
2 1 exactly. And then 8. So we came back to 8. So we write here and here. We collect all these things, whatever we outside bracket. So it becomes 8 by 29 becomes 0.4
vinculum.
4 vinculum 2, 1 vinculum 1, 5, 5 and 2. All the non-bracketed ones you have to collect. Now,
how much is equal to? 0.4 and vinculum 2 is how much?
3.8.
3.8.
1 and 8.
One vinculum 1 is? 1 vinculum 1 is?
0.9.
0.9, exactly. Very good. 0.9 and then 5.2.
Right.
Can you verify, calculator?
Yes, sir. 380,952 repeats.
380952. Now, is it, Colonel Sahib, you can comment whether is it too difficult, too heavy for the first level course? This negative and so on. Just a very neutral idea. I hope people will be doing it. They did it, no? It will be very enjoying. Ultimately, if you are able to do it, you are able to solve these negative problems, then you will find that you will become very expert and you will be well advanced, quite advanced in kind of thought that how to handle these numbers. But, please assess, Colonel Sahib, if you have any comments on this kindly, or you can comment. So I think it can be in the first level course itself. Although I want the reaction from the participants. Do you find it okay?
Non-mathematics.
I hope you should not be deprived with this one. Colonel Sahib, please tell me whether this is fine or not.
Ramesh Garu, you are saying something?
No, sir. I said because I think some of us have got mathematics background, so I think we are able to relate it, especially the binomial expansion. But people with no mathematics background might find it difficult, I guess.
No, but procedure here, I am not considering a binomial expansion, except that I am subtracting. That consideration I only giving, but the procedure wise, I am putting it within bracket by subtracting this 10 into remainder instead of plus with 10 into remainder minus this quotient. I am doing in the writing in the bracket and continue it. And also I am considering that when it comes, the whole thing become negative, and then with negative consideration is that I have to put it, write an expression or imagine an expression by which I will always find the remainder to be positive. So what should be my quotient so that remainder is positive in case of negative numbers? So I only consider that one. That's all. That's what -1 divided by 2 become 1 vinculum and 1. -5 divided by 2 became 3 vinculum and 1 quotient, like that way. 3 vinculum quotient and 1 remainder, that way. So any problem at that understanding? I think it will be a little practice. It will be all right. Okay, now we can. I will just again do. Here, this slide we did these things. What we did, we evaluated ourselves. Here actually, because this particular symbol, vinculum, came very close to this, actually. Very close it became. Sometimes you get confused that whether it's vinculum or not. 11 by 21, I evaluated. See, 11 by 21. 11 divided by 2, 5 quotient 1 remainder became 0.5. 10 minus 5 is also 5. 1 quotient 2 remainder became 8. 8 is 4 quotient 0, 2 quotient 1 remainder. 4 quotient 0 remainder, 0 vinculum 4. Vinculum 2 becomes quotient 0 remainder, 0, 2, 1 and 1, and becomes -1. And again, this becomes 11, came back to 11. So we did this 5 and 1. But it is here But again, we clear the vinculum. These two vinculums we clear. We got 523809. Cycles are, we did it with 8 by 21. So these things will get with these cycles will come. Calculating n by 7. N by something by 7. So you have two options. Either you write as 3n by 21 or you can, earlier we did multiply both the side by 7. So both way you can show in case of 7, ending in 7. I'll tell you. See. Comparison of positive and negative methods. Compare the Excel sheet snapshots, or it is an Excel sheet snapshot anyway, but you can do it yourself also. Positive and negative Bayesian method in case of methods in case of 1 by 21. Recurrence rate is 6. So in 1 by 21 could have been like this. 9 divided by 19. You start, because 1 by 21 is 9 by 189. 9 by 189. So we divide 9 by 19. So 9 by 19, 0 and 9. Because 90, again 90 divided by 4 is 14, 4 ja 76 plus 14. So the 144. Because very big, 117, 36, 171 becomes 9 quotient and 0 remainder, then 0 quotient 9 remainder, that way. And then it will remain, repeat. So that is the method, very big method. But here we did 1 divided by 2 only. Instead of 9 divided by 19, we did 1 divided by 2. But in all the negative, we have to consider 5, 3 becomes negative, and this thing, this. And finally, when we clear these vinculums, this becomes 47, this becomes 47, and this 2, 1 became 1, 9. So we got the same result. Here everything got positive, but here we got something got negative also, because you are following the negative method, and then there can be sometimes that where you got negative. So that is the idea, that vinculum we use the same way in the digits we use positive and negative numbers. We become more flexible or agile. You can say that we are quite fit for handling negative and positive numbers in the face value, like means vinculum positive number or negative, like vinculum in the in our number system. So that becomes quite conversant in that. So here we already did it, and here we did again by expression. I did, suppose we started with 14 by 31. We get a cycle of 15 numbers. 15 into 2 is 30. So 31 being a prime number, so it will have totally will be 30. So it will be 2 cycles of 15 length each. So like this we did 14 divided by 31. So 14 divided by 3 becomes 4 quotient, 2 remainder. Instead of 24, we do 20 minus 4, that is 16, 5 quotient, 1 remainder. That way it goes like this, and sometimes we go negative also. So that way we finally we clear the vinculums. Something by 35 by 51, this example is there. You can see yourself and do yourself this thing, so you'll be understood. This will be understood to you. Now, basic one method, something n by n 17. We can be denominators ending in 7, can have two different ways. Multiply both numerator and denominator by 7 to have denominator ending in 9, or multiply both numerator and denominator by 3 to have denominator ending in 3 and follow the negative method. Here you use positive method, here we use negative method. For example, 8 by 17 can be expressed as can be expressed as 56 by 119 or 24 by 51. Both are 8 by 17. Positive method is that start dividing 56 by 12. So 12. 56 we are starting divided by 15. 12. So it is 4 quotient to 8 remainder 84. 7 quotient 0 remainder, 0 quotient 7 remainder. Then again 5 quotient 10 remainder. That way it goes. Or negative method, 24 divided by 5. So 24 divided by 5. So 4 quotient 4 remainder. Again 40 minus 4 is 33. 7 quotient 44. 41, 36. 36. So 7 quotient 1 remainder. So instead of 17, you write 10 minus 7 is 3. 0 quotient 3 remainder. 30. Then 30 becomes 6 quotient 0 remainder. Because of this 0 remainder, it becomes minus 6. Minus 6 we divided by minus 6. Divided by 2 minus 6. Sorry, divided by, not divided by 2, but divided by 5. Divided by 5 is how much? How much is? Minus 2 quotient and 4 remainder. Because this minus 2 into 5 is minus 10. I add 4 to get minus 6. So that is the idea that remainder is always positive. Quotient can be positive and negative both, but remainder is always positive. So therefore this minus 2 came and even 4 minus 2 and becomes 42. So 8 quotient to remainder, that goes like this. And we got these two numbers negative. So you cleared the dream club and got these numbers. So that is the idea. So here I say exercises are recurring decimals. So there are exercises on the recurring decimals. You please do it in either positive, negative methods. In case of this ending in 9, it is already positive method. In case of 3, it is also positive method you use. Here you have to don't have to do any multiply. Here you multiply both sides into 3. Here you multiply by either by 3 for negative method or by 7 to have positive method. Here compulsorily you have to multiply. That's negative method. You don't multiply anything negative. Here you compulsorily you have a negative method. Here you always have a positive method. Here also multiply by 3 and you get multiply by 3. Here you get always positive method. Here multiplied by 3 to have negative method, this negative, or multiply by 7 to have positive method. Here you have option, and here you compulsorily have to negative method, otherwise it will be very big. So find at least 5 places of correct decimal. 5 places. You don't have to complete the cycle. You do 4, 5 places and then verify with calculator that you are in the right track. Okay. Periodicity. This much I will discuss and then I will end.
I think we will
Periodicity
see
is that
tomorrow. We will do this tomorrow because it takes a little time.
that this is just a consideration that periodicity actually it becomes this is something called repeat 9.
We have
How much fraction of repeat 9 becomes repeated? So 41 actually is a factor of 41, such a number is a factor of 99999. 5. So therefore you have 5 cycles. So here we are considering this consideration we have. We just look at it tomorrow we'll discuss. Then the divisibility will come cover tomorrow. Maybe that this last 2 slides I'll discuss tomorrow and then I'll go to divisibility. Okay, thank you. Namaskar.
yeah, thank you so much. So today is we will close this today at this point, and tomorrow we will continue. Let us thank the Guruji for today's class. And let us go for Prarthana by Krishna Kumar ji.
स्वस्तिः प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महीं महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथ्वी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान्मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्तिः 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 ॐ पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्तिः 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 सर्वे जना सुखिनो भवन्तु स्वस्ति
ధన్యవాదములండి కృష్ణ కుమార్ గారు. Thank you so much. Now let us go for Janagana Mana. Janagana Mana Adhinayaka Jaya He Bharata Bhagya Vidhata पंजाब सिंधु गुजरात मराठा द्राविड उत्कल वंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद. అందరికీ ధన్యవాదములు.